Good afternoon, students. I'll start with the class. This is the last topic of the chapter. That is formation of a differential equation. Or you can say form a differential equation. For this, you have to know that there will be something called as arbitrary constant. They are called as arbitrary constant, means the letters A, capital A, small a, B, M, capital M, small m. These are called as arbitrary constant. It could be capital H, small h, anything. Okay, other than normally these are your variables X, Y, U, V. These we use normally for variables. Constant we can use A, B, M, K also is there. Mostly these are the letters used for constants. P, Q also could. So these are called as arbitrary constants. So how to form a differential equation? So we have to see. So a differential equation, a equation will be given. Count number of arbitrary constants. How many arbitrary constants are there in that equation? Count a number of arbitrary constants in that equation. Now you have to differentiate the equation as many times as the arbitrary constant. If there are two arbitrary constants, two times you have to differentiate. If there are three arbitrary constants, you have to differentiate three times. That way. If there are four arbitrary constants, you have to take four times derivative. Differentiate. You have to differentiate three times. Three arbitrary constants means three times you have to differentiate. And the final equation, final answer must be free from arbitrary constant. Means no arbitrary constant should be left in the final answer. The final answer must be free from arbitrary constants. You have to make sure that you have to eliminate. Okay, so basically you have to eliminate arbitrary constants. But if there are two of them, no, you cannot differentiate three times. To eliminate. Two means two times only you can differentiate. You cannot go more than that. You cannot go less than that. Let's start with the first question. Let's just take a screenshot of this and keep in case they have not finished. Those who have joined late. Just take a screenshot and keep. Question is, form a differential equation by eliminating arbitrary constants. First question, simplest one will start. This is the equation given. We have to form a differential equation. How many arbitrary constants are there in this? Arbitrary constant 1, that is A. It is only 1. So how many times differentiate? Differentiate only one time. Always we have to differentiate with respect to x only. This will be dy by dx. What will be derivative of A? Can anyone tell me what will be the derivative of A? It's an arbitrary constant. What will be the derivative of A? Please answer quickly. Why all are wasting time? What is the derivative of A? What is derivative of a constant? I'm going to throw everyone out of the meeting now if you all are not responding.
Teacher, 0.
Yes, answer will be 0. That's simple it is. I don't know why I waste so much time. So that's the answer, because final answer is free from the constant. Only one time I have differentiated. The second. Anyways, I'll just go on teaching. You'll understand, don't understand. Anyways, y'all don't respond. I'll do my work. So second one is y is equals to ax plus b. So now arbitrary constant, there are two of them. So we have to differentiate it 2 times. When you differentiate, this will be dy by dx. So derivative of a is 1 and derivative of b will be 0 because the constant. Now again we have to differentiate, because we have to differentiate 2 times. This will be d square y, again 0. Derivative of a will be 0. So this is the answer. Final answer should not have a and b left in that, which is fine. There's no a and b left in the final answer. So that's your answer. Third one. If you notice, there's only one arbitrary constant. So we can differentiate only one time. When you differentiate, this will be dy by dx is equals to m. Derivative of x is 1. So dy by dx is m. Now, if you see the rules, you can differentiate it only one time. But now you can final answer should not have that arbitrary constant. So I cannot, this is not my final answer because m is still there. I have to eliminate m. But now again I cannot differentiate to make this 0 because as per the rule I can differentiate only one time. So I just cannot differentiate it again. So what I need to do is I have to do some substitution so that m goes. So what I'll do is mark this as equation 1, mark this as equation 2, put value of 2 from value of m from equation 2 in equation 1. So just do the substitution. So y is equals to mx, m is nothing but, the answer is x divided by. I just put this value back here so that the final answer does not have m. Or you can use the other way around. Instead of m, no, I can put, what is m value? Y upon x. So here I can put y upon x. And then x will go on this side. Same answer you will get in both the cases. Like that. Or what you can do from here, you know that y by x is m. So here you put dy by dx is m. M is nothing but x will come up here. Same answer. Fourth one. Now arbitrary constants, there are two of them. So you can differentiate it only two times. And differentiate it for the first time. Derivative of 1 by x is always minus 1 by x square. Know that derivative of 1 by x is minus 1 by x square. How you get? Take this as x raised to minus 1. Minus 1. So it will be minus 1 x raised to minus 2. Then if you bring the power down, the derivative of 1 by x is always minus 1 by x square. It's a fixed formula. So derivative of a into 1 by x is minus 1 by x square. Derivative of b will be anyway 0. Now I know that only one chance I have. Okay, I have only one chance left to differentiate. And in that, I have to eliminate a. Now along with this, if it is there, it will never go. So one option I have is I'll make a single. I'll try to take this on the other side. So what I'll do is x square I'll take on the other side. And I'll keep minus a here only. This is anyway 0. So before differentiating, I just kept a single. So that when I differentiate, automatically this a will become 0. Otherwise, if I take like this only and distribute, again we'll have to do the substitution like question number 3. Best option is keep this single and then differentiate. Now this is u into v root. So we know u into v is u into derivative of this. Already it is dy by dx. One more time, if you take derivative of dy by dx, it will become d square y upon dx. Then v into derivative of u. Derivative of x square is 2x. U into derivative of v plus v into derivative of v. Derivative of minus a is 0 because the constant. So that is the answer. Okay, x is common. What you can do, just divide by x. X and x will cancel. Divide throughout by x because x was common. So that is the answer. There are two arbitrary constants. So I can differentiate it only 2 times. But see, now this is also having x, this is also having x term. If I try to differentiate, both will not get eliminated. I want to eliminate one of them at least one time, one at a time when you are differentiating. So what I'll do, I'll try to make any one of them single. And if it's there along with x, it will never become 0. So I'll try to get rid of this. So I'll multiply throughout by x. Multiply the equation throughout by x. Multiply by x throughout. This will be xy, ax square, there will come b.
Excuse me, teacher.
Yeah. Oh, wait, you can't see.
Teacher screen is not visible.
Okay. So we have to try to eliminate this one. Only if it is single, it will become 0. So I'm trying to make b single. So who is there along with b? X is there. If I want to get rid of this, I multiply throughout the equation by x. X and x is this way. Now I can differentiate. So when I differentiate, b will automatically go. Now this is again u into v rule. Apply u into v. U into derivative of v plus derivative of x is 1. Derivative of x square is 2x and this will be 0. Now what I'll do is again try to make, okay, we'll try to get rid of this x. Why? I'll make 2a single. If I try to keep 2a, derivative of 2a will be 0 because this is also constant, this is also constant. So I'll try to get rid because only one more chance I have to eliminate a. So before differentiating, if I differentiate straight away, what is going to happen? Answer will be 2a into 1. So that a will remain then. If it is there along with x, if I differentiate. So before that, what I'll do is just divide throughout by x. So this and this will go. This will become y upon x. And now you differentiate. Only 2 times I could. That's the final differentiation. Derivative of dy by dx again is d square y upon dx square. Again, if you want to take derivative, it will always become square. Now this is u upon v rule. Apply u upon v rule. U upon v is v into derivative of u. Derivative of y is dy by dx minus u into derivative of v upon v square. Normal derivative formula you should know, u into v rule. V into derivative of u minus u into derivative of v upon v square. And this is 0. This whole term I take on the other side. Or I can cross multiply also. Just cross multiply this x square, or best option, multiply throughout by x square. Why I don't want to keep anything in terms of fraction. I want to get rid of this x square which is there in the denominator. So multiply throughout by x square. So answer will be x square. So when I multiply x square to this term, this will cancel and I'll get 0 into x square is anyways x square. This is 0. Multiply throughout by x. So this is the answer. I don't want to keep anything in the denominator fraction. This. That's why I multiply throughout by x. We can cross multiply also. X square plus this upon this. Then this will go up. 0 into x square will anyways become 0 1. Pope John students 100% you all are having these questions. I checked on the notebook. She has already started with that. 2 problems I think she has done. So definitely she'll do more. And it's there on the preparatory also. The latest preparatory means the last year which I have with the deleted portion also they have put this problem. Now how many arbitrary constants are there? 2 of them. So I can differentiate 2 times. So you have, see, you can either try to divide everything by x. So this will, a will become single then. That also option you have, like the previous problem. You do that, same answer you'll get. Or in case you don't want to do it, is u upon v rule, and you don't want to try to eliminate this way. Means what? By making this a single and all, there's one more method, normal method also, that also I'll show. One option is divide by x. So this will become y upon x, a will become single, this will be dx. Then you differentiate, a will become 0, this you have to apply u upon v rule. That one option. Or directly also you can differentiate. Only thing you have to substitute the values. Whichever you all find easy, you'll use. Okay. One time I've differentiated, now I'll differentiate it for the second time. Derivative of x will be 1. So what has happened is now b is left. Now this is going to become a problem. I cannot differentiate one more time because I'm done differentiating. Now you have to try to substitute the values. So what is the value of b? B is nothing but half d square y upon dx square. So put this value here, find the value of a. In equation 1 you can put 3. Put. So it becomes lengthy. That's the only problem. You don't try to eliminate it first only, no? You don't make a single and go like this, then you have to do substitution method. Put value of b in equation 2. Why am I doing this? Because my final answer should not have a and b left. Now here what has happened, value of this b is left. I want to get rid of this b by doing some substitution because I cannot differentiate more than 2 times. In equation 2 I'll put the equation 2, what it will become? What is value of a? Dy by dx minus x d square y upon dx square is a. Bring this full term on the other side. So I got the value of a, I got the value of b. This is the value of a and b I found out. What I did, found out b, put the value of b here, I got the value of a. A is nothing but take this term on this side. So put now final, put the values of a and b in equation 1. Like how in problem number 3 we had done same way. We had substituted the value of m back in the main equation. Like that. Put value of a and b in equation 1. This is equation 1. A is this. That is this x. And b is this. Now you have to open up and solve. Multiply inside. Right like this. If you notice, these are the same term. This term is same. This term is also same. So minus 1a plus half a is how much? Like we are minusing. Minus 1 plus half is nothing but half. You can take out x square dx. This common also. You take out common. What remains is minus 1 plus half. And this is nothing but half. Final answer is only thing it becomes lengthy. This method. And still you don't want fraction. You can still this also you can avoid. Multiply it throughout by 2. So 2y no more fraction. Next one. These are simple ones. These are like repeating types. Repeating type. Whenever you have e, because derivative of e raised to x is e raised to x only again. So it keeps repeating. So these are the repeating type of problem. How many arbitrary constants are there? 2. How many times you can differentiate? Only 2 times. Arbitrary constant means this constant a and b. Now we'll differentiate this. This will be dy by dx. Derivative of e raised to 3x is e raised to 3x into 3 because coefficient of x is 3. Whenever we are differentiating, we always multiply. And whenever we are integrating, we always divide. So this is b e raised to minus 3x is this only, but extra you have to multiply it by minus 3 because extra derivative of minus 3x is minus. Always it is that. What did you get? dy by dx 3a raised to 3x minus 3b. Now only one more time we are left to differentiate. 2 times you can differentiate. This will become d square y upon dx square. 3a is again a coefficient. E raised to 3x. Again we have to take derivative into 3. Again e raised to x is minus into minus. If you simplify, this is d square y upon dx square. 3a e raised, 9 it will become. Minus into minus is plus. What is common? 9 is common. And always this type problem, no repeating type, it ends up again like same like your question which is given. After differentiating it 2 times, just see, look at this equation 1. Isn't it back to your same equation? You will get same thing after differentiating it 2 times. So that's nothing but y. From where you got? From equation 1. Value of that. So the final answer doesn't have a and b now. So that is the answer. Or you can write this way also. C square y upon dx square minus 9y is equals to this or this. No matter how you write, it's correct. Similar question. You can differentiate it. Again, two arbitrary constants, only we can differentiate only two times. Derivative of cos of x is minus sin x into extra, this 4, because coefficient of 4x is 4. Derivative of dy by dx is minus 4a again we have to differentiate one more time. Derivative of sin is cos 4x into 4 minus sin 4x into 4. So d square y upon dx square minus 16 is common. You'll get it as minus 16 here also, and get it as minus 16 here also. Again, this is same like it 1 only. D square y upon dx square plus 16y is equals to 0. Ninth one. So again, arbitrary constants, only two of them are there. So we can differentiate only two times. Now a is anyways coefficient, sine of something. You know, sine x is derivative is cos x. So whatever is inside a bracket, we have to imagine it as x. This, whatever is inside the bracket, it is like x. So derivative of sine x is cos x. So x is nothing but log x. But was it a plain x? No. You have to take extra derivative of log x, which is 1 by x. Same way, derivative of cos of something is sine, minus sine, into extra derivative of log x. No, then get it. X is common both the places. There's x here also, there's x here also. Now if you directly go to differentiate one more time, what is going to happen is it will get complicated. This is u upon v, it will become u upon v rule. So instead of complicating this, what I do, I'll just take this x on the other side just before differentiating, because again I know that these are repeating types, it will become same like equation 1 only. So x I brought this side. Now I can differentiate. Now this is okay, u into v, better than u upon v. Apply u into v rule now. U into derivative of v plus v into derivative of u. Cos of log x is minus sine of log x into 1 by x. Sine x derivative is cos x into extra derivative. If you don't know the derivatives, go back, check the derivatives chapter, because it's not possible to explain the same thing over and over again. You also have to put some efforts in learning. Basic derivatives, at least you should know what is derivative of sine x, what is derivative of cos x. So again, this is x is common in the denominator. Multiply here this side. And this is common, minus is common. And if you notice, this is nothing but from equation 1, the same question is repeated by. Can open up the bracket, x square d square y upon dx square. Yes, this is the answer. Next one. Now if you see, there are two arbitrary constants. We can differentiate it two times. Now this is not repeating type. Repeating types are this, and you have one is same thing and the other one is this. You have A, then there's B also, but this is only single. So even if you go on differentiating now directly, this will be complicated, u into v root. This will never get eliminated only then. Okay, so whenever you have like this an e raised to x single term multiplication, always take this on this side. What you do, bring this here, y upon 3 raised to x, because automatically this will become free. So when you take derivative, it will become 0. But otherwise what would happen, this would be a u into derivative of v plus v into this would never go, will not get eliminated. So I'll take this up. And now for the first time I'm differentiating. So when I differentiate, automatically a will go. So this is u into v root, u into derivative of v. So e raised to, this is e raised to x only, but extra derivative of this plus v I have to copy paste as it is, take derivative of u, dy by dx. Derivative of a is 0, derivative of x is 1. Now this is in e raised to minus 3x is common in both the cases. Or instead of complicating, you can just write this is minus 3y. Now only one time is left to differentiate. Now you know that b is anyway single, so automatically it will go, it will become 0. This is u, again this is v, this is u, this is v. Minus 3 can take out common. Coefficient doesn't matter. Coefficient you have to keep out and apply the formula for u into v. Y is u, v is this. So u into derivative of this. So derivative of e raised to minus 3x into minus 3 plus v into derivative of u. Then again u into v rule here also. Now already there is dy by dx. Again derivative of this will become d square y upon dx plus v into derivative of u now. Then derivative of b is 0 because it's a single constant. Multiply this minus 3 inside. Minus into minus is plus. And this will become 9. Minus 3 into minus 3 is plus 9. If you notice, these are the same terms. Minus 3 will become minus 6. and everywhere e raised to minus 3x is common. So just divide everything by e raised to minus 3x throughout the equation. Whatever is common, you can just remove it off. Answer will be 9y. Usually, we write in the correct order with higher term first. We can write this way. Highest order derivative. You can same complicated here. There's u and this is v. So instead of that, and take this down here. This will be, take it on top. And now you can differentiate. This is u into v rule. U into derivative e raised to minus x is e raised to minus x into extra minus 1 because coefficient of x is minus, plus v into derivative of u. Derivative of cos x minus sin x. Derivative of sin x is cos x. You will get like this. Now you can differentiate again. When you differentiate, this is again u into v rule. Minus is out. dy by dx is y. Again u into v rule. Which is equals to a cos x plus b minus sin. Open up the bracket. minus into minus is plus, minus common, this term and this term is same, so you get minus 2 and look in the equation 1. What was the question given? Just the main question was this: y is equals to e raised to x a cos x. So this was the question given. Now what is the value of this a cos x? The second statement, no, you mark it as equation 1. We have done this, no? After this, e raised to x were taken down. To mark that as equation 1. The main question was this. After that, what we did? This step. So what is the value of a cos x plus b sin x? Nothing but from equation 1. Value of a cos x plus b sin x is y upon e raised to x. Take this e raised to x and multiply to all the terms. E raised to x will go and get multiplied to all the terms. It will go up. So e raised to minus x into e raised to plus x is always equals to 1. So this part will go. So this one divided. E raised to x will go. Why you bring this side? Next one. So I'm just trying to see which one to give. Okay. Solve this one. Next one. Or a into x minus h. So arbitrary constants, two of them, that is a and h. So you can differentiate it only 2 times. So before differentiating, I just open up the bracket just to avoid u into v. If you see, this whole thing is a constant because a is also constant, h is also constant, and 4 is also constant. So the whole thing is a constant. First time I differentiate, this will be 2y. Derivative of y square is 2y. Again, extra dy by dx because we are differentiating with respect to x. Derivative of x square is 2x. Derivative of y square is 2y. But since it is y and this is x, extra always dy by dx. This is a coefficient. Derivative of x is 1 and this will be 0. So y dy by dx will be equals to 2a. And now finally we have to differentiate. Only you can differentiate it 2 times. So when you differentiate, use u into v rule. So y d square y upon dx square plus dy by dx into derivative of y. Derivative of y is again dy by dx. This is u, derivative of v. So derivative of dy by dx is again when you are differentiating, it will become square. Plus v I am copy pasting as it is and taking derivative of y. Derivative of y is what? Dy by dx. This will be 0. A into a is nothing but a square. So this is different and this is different. Just here. This is dy by dx the whole square. This term is different. This term is different. This is done. Now the problem here is only there is one arbitrary constant. See, letter is same. So even there are 2 times arbitrary constant to be taken only one because the only if there are different letters then they are considered to be different constant. Even though a is there 2 times, still which is the arbitrary constant present here a. So it whether is there 3 times, 4 times the same a to be considered as just one arbitrary constant. So you can differentiate it only one time. So when you differentiate, this will be dy by dx. A is anyways coefficient. This we have to assume it to be x square. Whatever is inside the bracket, you have to imagine it as x square. So derivative of x square is 2x. But into extra derivative of what is the inside the bracket. So derivative of 1, so we have to always multiply by what is the inside the bracket. First derivative of x square into extra derivative of what is the inside. This is 2x raised to 1. And then now I cannot do anything else. I cannot differentiate it one more time. But I'm still having a left in the answer. So I have to get rid of that. So what answer I'm getting here now? Dy by dx. Put this as equation 1. One thing, if I want to eliminate something, so what I can do is and divide equation 1 by 2, because there is no other way to solve this. Or else there's one more, put what is x minus a, 1 upon 2a times this, and then this a is how much? 1 by 2 times dy by dx. We can try that way also. Let's see if it's getting eliminated. From here there are two options. One is dy by dx. Just give a try on this. And this a is also from here only one more equation I'll make. If I want to what is the value of a, suppose x minus a is this. The value of a is this two terms I'll take down. So put value of, I'll just give a try. Let's see if it's working. I want to finally eliminate a from this. So a value is this, and x minus a value is this. No, again what is going to happen? See, a is still remaining. Okay, it will be a loop. So the only way is we'll divide the equation 1 by equation 2. So this was equation 1, this is equation 2. So we'll divide equation 1 by equation 2. This is a into x minus a the whole square. So here one advantage is that a and a will cancel, and this one will cancel with this. So y upon dy by dx is equals to x minus a. So instead of using the dy by dx, no, I'll use it as y1. No? It becomes easier to solve then. See, we know that y is always dy by dx can always be written as y1. D square y upon dx square is always written as y2. Same third derivative can be written as y3 that way. So just instead of dy by dx every time, I just use this. It becomes easier. What I'll do, here I'll bring this side take on the other side. There's 2 is also there, no? So 2 I'll bring here. Here I'll bring this side. This fellow I'll take on the other. So minus a will become plus a. This side if I take, this will become minus. Basically, I found what is the value of a. A is nothing but x minus 2y upon y1. Mark this as equation 3, this as 4. Now you can put value of x minus a and a from equation 3 and 4 in equation 1. So what is equation 1? Y is equals to x. What is a value here? X minus 2y upon y. What is x minus a value? Is a square. This you cross multiply. Now multiply this 4y2 inside. This will be 8. This will become cube. Y1 cube. This 4y square I multiplied inside to both the terms. Y1 into y1 square is y1 cube. Wait. Okay. So now just take it on the other side. Now only simplification, simple one. Y into y1 cube If anything is common, you can divide. Y is common. Everywhere y is common. So this will be y1 cube. Done. Okay, so this using elimination method. And one more do. One last one. Three times y minus a. So there are two arbitrary constants. So you can differentiate it two times. So first time if I differentiate, before differentiating, I just open up the bracket. Now it different. dy by dx. This is a constant. It will anyways become 0. So next step what I'll do is I'll try to eliminate this b. 3 and 3 also will cancel. Dy by dx upon x square is equals to b. The second time when I differentiate, automatically b will get eliminated. This is u upon v rule. So v into derivative of u minus u into derivative of v upon v square is equals to 0. This whole thing will go and get multiplied to 0 and become 0. I've used u upon v rule. 0 into x raised to 4 is 0 only. Anything common, x is common. You can divide by x. This is anyway 0. This is done. One more is there. I've solved enough problems on this. X minus a the whole square is equals to 1. To differentiate, so when you differentiate, this is assume it to be, now there's only one arbitrary constant. So you can differentiate it only one time. So differentiate with respect to x. So this is x square. Derivative of x square is 2x into extra derivative. What is the inside? Derivative of y square is 2y into dy by dx, because this is y and we are differentiating with respect to x. And derivative of 1 is anyway 0. Now we cannot do anything. Now only the option is to substitute. First thing what you can do is divide by 2. The value of x minus a is nothing but, after dividing you'll get this. So x minus a is y dy by dx. Mark this as equation 1, mark this as equation 2. Put value of x minus a from 2 in equation 1. Because we cannot differentiate it one more time. Only once we have to differentiate. And what is happening if I cannot leave my answer like this. A should not be there. No arbitrary constant. So that's why I'm trying to substitute it back in the main equation. What is x minus a? Y dy by d. There's a square term. This is the answer. If you want, you can take out y square common also. Okay. Similar concept. Any given equation, you have to see how many arbitrary constants are there. Those many times only you have to differentiate. Even after differentiating, if you're not, if arbitrary constant is still remaining, then you have to try to substitute and then eliminate a constant. So with this, I finished with the chapter. All the topics have been covered. Even though there's a confusion whether it's eliminated or not eliminated, I've solved them. Up to you all whether you want to study or not. Okay. Those are finished. And next class, I'll start with probability. I took the attendance.